Okay.
So we're live now.
All right.
Okay. So there's a few questions here. So preparation assignment. The first one says, what is the sampling distribution? So there's actually a pretty good definition found for it somewhere here. Let's see if we can see it again.
I've got a probability distribution of a statistic.
Yeah.
Obtained through a large number of samples drawn from a specific population.
Yeah, exactly. I think that's right. Cool. So the next one says, shape of a sampling distribution of the sample mean when the data are normally distributed. So what I was able to get from like the preparation was like, if it's a normally distributed, even if it's like 2 numbers or 4, the sample distribution will be normally distributed because the data is already normally distributed, right? Okay. What is the shape of the, so number 3 now, what is the shape of the distribution of sample means when the data are not normally distributed, but the sample size is large? So for that one, right, it's a central limit theorem. So even if your data is not normally distributed, but you have like 100 samples, for instance, then your distribution will appear to be normal, right?
Yeah, approximately normal.
Yeah, you're right. Approximately normal is a key word there. Yeah. Cool. How does the shape of the distribution of sample means change when the sample size is increased? How does the shape of the distribution of sample means change?
I've got it gets closer to normal.
Okay.
And the standard deviation decreases.
Or gets closer to normal.
Yes.
Okay. And standard deviation decreases. What is the difference between central limit theorem and law of large numbers? So I understood the law of large numbers basically to mean it deals more with accuracy. So for instance, if you flip a coin like 5 times and you get like a head 4 times, but the more times you flip it, the closer you'll get to like the actual, probability to, like, in other words, like 1/2, right? Whereas central limit theorem, I think it's like, it just basically means having like a ton of data, which will make your distribution look normal. I don't know. That's kind of what I understood from it.
Yeah.
Approximately normal, right? That's the keyword. Cool. Difference between when is X normally distributed?
Sample mean, when sample mean normally distributed.
Yep.
Yep. Normally distributed when if the population is normal or if the sample is large.
Cool. Okay. So part 2. I didn't, but I just like watched the videos and then just did the first part.
Part 2, I did part 2.
Yeah.
I didn't go to what is it?
The .org, the website.
I didn't go to random.org. I just picked 5 at random, and
yeah.
And I found the mean, and by looking at the graph, I was just right in, right where the mean is supposed to be on the graph. I got like 46,600
Yeah, yeah, because like
is what I had.
the mean of the mean is the mean, right? That's like one of the things.
Yeah, yeah,
Yeah, yeah.
yeah. And
Okay.
so it was not unusual. That's what it's supposed to be. Um, Now for number 8,
Yeah.
I I really didn't. I need to do more studying on the videos because
Okay.
I, I started watching the videos yesterday, and
Okay.
it kind of shows you how to do that.
Yeah, that's what I did. I just watched the videos and I opened up the quiz and it doesn't look too bad and I think we can get through it together. So if you want to the quiz
I'm
up now.
trying to get there. I'm not at my house. I'm at my mom's. I've got some family that came in,
Yeah.
and her internet is it is terribly slow.
It's kind of rough.
Yeah, so I've been trying to get to the quiz since we started the meeting,
Oh no.
and I'm still not there yet.
Okay.
Yeah, but I'm close now.
Okay. Let's see here. Um so I think I missed this. Where are you from? Like where you're not in Rexburg, are you?
No, 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 no. I'm from East Tennessee,
Oh, okay,
and
cool. Tennessee.
yeah, the southern accent. Um,
Yeah. Cool.
all right, I have opened the quiz. I am there.
Oh, perfect. Cool. Yeah, so this the first says if needed, here's a link for the probability applet. Okay. Do not round until your calculation is complete. Okay, so question 3. Are we okay for that one?
Yes, yes.
Okay. So when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is skewed right? So I would think that it's A, skewed right, because it's not saying that it's normal, right? Because if it was n equals 5, but it's normal, then it would be normal. But because it says it's skewed right and it's such a small number, I think it would stay skewed right. That's my guess for that one.
I,
What are your
I
thoughts?
think so. In the reading,
Yeah, yeah.
there was a. Did you see that? They gave you some sort of like simulation or something. I don't know what it was.
Okay. In the textbook.
Uh, you could, yeah, in the textbook.
Let's see here.
Let's see.
Um,
Yeah, it goes through this big spiel about going through all these different, going through normals, right skewed, all that, and then how the sample mean relates to the population mean.
uh-huh.
And I think you're right. I think right skewed mean is right skewed, and the sample mean is going to be right skewed.
Right. I think that's what it is. Yeah. Um, so number 4, when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? Right. So this is the central limit theorem, right? Because you have such a large sample size, it's just going to make an approximately normal distribution, even though it's right skewed.
Um,
Right. What do you think?
that where okay. I've just about got it pulled up here.
Okay. Is it the one that says online stat book with like the graphs and all that stuff?
Yeah.
Okay.
Yeah, that's the one. Here. I'm not sure how that. Still not 100% sure how the graph actually works.
Yeah. So I'm pretty sure that one would be normal because so central limit theorem says as sample size n increases and becomes large, the distribution of sample means becomes approximately normal. That's like the definition, right? So
Okay. Yeah.
I'm pretty sure that's what happened. It just would be an approximately normal distribution. So 5?
Yes.
Okay, cool.
So
when you are taking a sample, yes, go for it. What were you saying?
I said I would say that 5 is normal.
Yeah, definitely. Yeah, normal. Because like even though it's a small number, the parent population, right, is normally distributed. Therefore, the sample size or the distribution would be normal.
And number
Okay.
6, it would have to be normal too because this is the same. It's a normal distribution, but it's just got the larger sample size.
Yeah, I just think they're trying to trip you up. They're trying to make you like think about it.
Get you to do a little critical thinking.
Yeah. Okay, so 7. When would the distribution of means be normally distributed? Choose all correct. So data are drawn from a population that is normally distributed, and the sample size is small. I think yes, because if the parent population is normal, then even if the sample is small, it'll still be normal.
Yes. Data are drawn from a population that is normally distributed, and the sample size is large. I'd say yes as well.
Yeah. Also, yeah, you're right. So the second one. I would say no. Yeah, the last one. I would say no for the third one. Which of the following gives the best explanation of the central limit theorem? Okay. So not the second one. It's already too weird. Parent population. So not the first one either, right? Because
yeah, no, not the first one either.
Not the first, not the second. So it's between third and fourth. So yeah, I think it's the last one. I think.
Yeah, I'll go with that.
Yeah, because it kind of has that one keyword, right? So if a sample size is large, the shape of the distribution sample means will be approximate normal, right? Whereas I think the other one is actually the law of large numbers, number 3. Okay, so now number 9. Let x be a random variable, population mean 10, population standard deviation 6, sample size 36. What does the mean? 10, right? So the mean of the mean is the mean. I
Are
think.
those like trying to be trick questions or something? Or?
Um, I think that one is. So let x be a random variable. Mean 10 and population distribution 6. Suppose no size and mean. I feel like number 9 is 10. I don't know what else it would be. Although number 10, I think you have to actually do a formula for number 10. You take like the 6 and then you get the square root of 36 and divided by 6, so that'd be 1, right? It's kind of my guess right there for the 10. Standard deviation of a distribution of sample means is the sigma over square root n, so the square root of n. So square root of n is 6, right? And then you divide,
Yes.
or no, am I wrong?
Well, the square root of n is 6, yes.
Okay. And then you just divided that by 6 because that's the standard deviation, so that'd be 1, I think.
1. Yep.
Okay.
Gotta be 1.
Yep.
Number 10, what is the standard?
Yeah, go for it.
I think the wrong one. Number 11, regardless of the distribution of the population, if the sample size is large, what would be the shape or the distribution of the sample mean? I'm going to say normal.
Yep.
Say that the law of large numbers. Let's see. That might be the central limit theorem. I don't know. Number 12.
Yeah, that's my my first guess was actually central limit theorem, but now I'm just like, I'm curious to why they're not asking us anything about law of large numbers, you know?
Yeah.
It's weird. See,
I still
regardless, what do you think?
I think it's central limit theorem.
Yeah, okay. I feel like it's that one too, because it says regardless of the distribution of the population, right? So it's kind of like saying, even if your distribution is right skewed or left skewed, if your sample size is large, then your distribution will be approximately normal.
Right. Well, let's see what happens.
Real quick before we submit it, let me just go run through it real quick with you. So for number 3, you put skewed right, right?
3.
Skewed right.
Oops. Hold on. I've got to go back. I've already.
Oh, you're good.
Let me. I've already got mine submitting.
Oh, sure. Yeah, no problem.
Let me look back through mine and I'll see what it says. And
okay, yeah, then we can do it again. That's fine.
I got so I got 100%. So number 3.
Yeah, just yes, I'm happy. Okay. So
number 3
was it? Is it skewed right? Right.
Yes. 4 is normal. 5 is normal, and 6 is normal.
Is A, B, and then D, right? 1,
Yes.
2, 4. Is
Yeah, 8 would be D.
Yeah.
9 is
10.
10. 10 is 1. And 11 is normal.
Okay.
12 is central limit theorem.
Perfect. Okay, thanks so much. I'll submit it, and then and I'll put that video on the group collaboration thing.
Okay, cool. Thanks. Yeah, just be sure to put both our names.
Yeah, that's too bad that Jared wasn't able to make it.
Yeah, I hate that.
All right. Well, thanks.
Okay.
Have a good one.
Yeah, you too, man. Bye-bye.
See you.